Welcome to another episode of AI 10X brought to you by 10 Leaves.
Glad to be here for this one. It's a big topic today.
It really is. So I want you, the listener, to just imagine something for a second. Imagine looking up at a skyscraper being built right in the middle of your city, but it is completely silent.
Which is almost impossible to picture, right?
Right. I mean, no shouting over the roar of diesel engines.
Yeah.
No warning sirens going off. No human beings balancing on those narrow steel girders 50 stories up in the wind.
Just completely quiet.
Yeah,
Okay.
just a synchronized, invisible digital brain effortlessly pulling the physical world out of the dirt. Because usually you look at your phone, you look at your computer monitor, and there it is. Artificial intelligence is safely trapped behind glass.
Safely in the digital box.
Exactly. You've seen it, write code or draft emails and generate art. But today, we are shattering that glass. Today, we're taking AI off your screen to look at how it's becoming the literal architect of your physical reality.
And we are witnessing a fundamental leap here. I mean, we are going from processing pixels to pouring concrete. It changes our entire physical footprint.
It really does. So for this deep dive, we are pulling from a fascinating source provided by 10 Leaves. It's titled Architecting Tomorrow, AI and the Automated City. And our mission today is to just, map out this massive transition.
Right, because it touches everything.
Everything. We're exploring how artificial intelligence is stepping into the real world to completely automate and transform construction and city building. And to help guide us through this entire landscape, I'm joined, as always, by our resident expert.
Thanks. I'm really excited to dig into this.
So to set the stage for you listening, the source material makes it abundantly clear that the traditional manual, muscle-powered era of construction, an era humanity has relied on for thousands of years, is effectively sunsetting.
Yeah, it's entirely giving way to a future where the physical execution of building on the ground and the cognitive macro-level planning of an entire city are fundamentally intertwined, and they're directed by artificial intelligence.
Okay, let's unpack this. Because to really grasp the sheer scale of an automated city, we need to start at the ground level.
We have to start in the dirt.
Right, we need to look at the dirt, the steel, the site itself. Our source establishes this clear division of labor in this new paradigm. Robotics are handling the repetitive physical tasks, while AI is managing the planning, the safety, and the efficiency.
The physical and the cognitive split.
Yes. And I was thinking about how to visualize this. Think of a modern construction site as a high-stakes orchestra. The robotics, they were the rhythm section, right? Endlessly and perfectly performing the repetitive beats. The heavy lifting, the repetitive tasks.
I like that. They're keeping the tempo.
Exactly. While the AI is the conductor, it's ensuring everyone comes in at the exact right time for efficiency, and crucially, making sure no one falls off the stage, which is the safety aspect.
That's a good way to look at it, but I might actually tweak that analogy just a little bit.
Oh yeah, go for it.
Well, an orchestra plays a finished, static score, right? They know the notes before they sit down. But the source material describes something much more fluid. It's really more like a biological nervous system.
A nervous system. Okay, walk me through that.
So the AI is the central brain, obviously. But it isn't just waving a baton from afar. It's actually feeling the physical stress, the pain, if you will, through the sensors on the robots. Those are its nerve endings.
Oh, well, so it's literally feeling the site.
Yeah, it's constantly reacting to chaos. The AI acts as this cognitive layer over the physical robotics, continuously rewriting the instructions in real time. So say a gust of wind shifts a steel beam by just 2 millimeters.
Okay.
The AI feels that shift through the robotic arm's sensors and adjusts the microtension of the grip in milliseconds.
See, I have to push back on this, though, or at least challenge the premise.
Sure, what's the hang-up?
You're talking about a hyper-responsive nervous system. But a construction site isn't some sterile laboratory, It rains, sinkholes open up, the steel supplier ships a beam that is slightly warped.
Real-world problems.
Right. If robotics are doing the repetitive work and AI is managing the site, does this mean the chaotic, noisy, unpredictable construction sites we are used to walking past are actually going to become quiet, hyper-organized environments? How does a purely digital brain handle real-world physical mud?
What's fascinating here is that the digital brain doesn't treat mud or warped steel as an unexpected crisis. It treats them as real-time data inputs.
Just more data.
Exactly. I mean, think about why human construction sites are noisy and chaotic in the first place. It's because humans communicate poorly under stress.
That is very true. Lots of yelling.
Right. When a truck gets stuck in the mud, human workers have to literally stop what they're doing, shout over live machinery, physically assess the delay, and then manually reallocate the labor.
It's a huge bottleneck.
But the AI, on the other hand, ingests real-time environmental data. It's using LiDAR, it's tracking weather patterns, checking material weight limits, and it instantly recalculates the physics of the entire site.
So it doesn't even pause.
No pause at all. If that mud delays a truck by, say, 4 minutes, the AI automatically reroutes the lifting drones to a secondary task so seamlessly that the bottleneck is just mathematically eliminated.
That is wild.
Yeah.
So it's removing the human reaction time entirely. The unpredictability isn't a disaster. It's literally just a new variable in a massive, constantly updating equation.
Precisely. A machine doesn't get distracted by a sudden loud noise, It doesn't mishear a shouted instruction from across the site.
It doesn't need a coffee break.
Exactly. And crucially, it doesn't suffer from a lack of sleep, which fundamentally compromises human reaction time. By applying this cognitive AI layer, you are completely erasing the element of human error from tasks involving heavy machinery and extreme danger.
Which is huge for safety. But I was thinking about this. That robotic ballet on the ground, that flawless, real-time nervous system reaction we just talked about,
Yeah.
that's actually impossible if the AI is just reacting blindly.
Oh, absolutely.
Like for a machine to move with that kind of crazy precision, it has to know the exact structural future of that building before the first shovel ever hits the dirt. Which means the real building doesn't happen on the site at all, does it?
Not at all. It happens in the simulation. The physical execution we just described is entirely reliant on a flawless digital preparation phase.
Here's where it gets really interesting. Because the source notes that AI is simulating entire cities to optimize infrastructure before any actual construction begins.
Entire cities, not just one building.
Right. And for anyone listening, we really need to elevate this concept beyond a simple video game. Like, this isn't just a massive game of SimCity where you pop down a fire station and hope for the best.
No, it's infinitely more complex than that.
We are essentially building the city digitally, running it, testing it, and seeing where the traffic jams or power failures are before we pour a single drop of concrete. It's generative design.
Yeah, the AI isn't just taking a human architect's blueprint and checking the math. It is generating these alien...
We ignore detours, we jaywalk, we drop our coffee on the subway tracks. How does simulating a city actually guarantee that the physical infrastructure will work perfectly in the real, unpredictable world?
If we connect this to the bigger picture, the answer lies in understanding what human planners historically fail to see.
Okay, what is this?
Well, human city planners have always had to rely on models that represent, basically, a best guess based on historical data. A human can foresee a traffic bottleneck at a specific downtown intersection. That's easy.
Sure, we know where the rush hour traffic is.
Right. But what a human struggles to spot is a complex cascading failure.
Okay, break down a cascading failure for me. Give me the domino effect of how that happens.
Let's trace a hypothetical sequence. Imagine a scenario where a localized grid fluctuation during a severe heat wave causes a brief power dip. Just a few seconds.
Happens all the time.
Yep. Now, that dip slightly delays a transit hub's automated scheduling by 3 minutes. That minor delay pushes an unexpected volume of, let's say, thousands of frustrated pedestrians out onto a secondary elevated walkway.
Oh, I see where this is going.
Now, that walkway wasn't originally designed for that specific sustained weight distribution along its left side. A human planner cannot easily hold all those intersecting variables, the weather, power grids, transit schedules, and material stress limits in their mind simultaneously.
Because to a human, those are 4 completely different departments. The power company doesn't talk to the walkway architect.
Exactly. But an AI simulating an entire city sees them as one interconnected organism. It doesn't just run one simulation. It tests thousands of variations of a city's infrastructure in seconds.
So it's actively hunting for that exact bizarre scenario.
Yes, it throws that exact heat wave and power dip at the digital city millions of times, just observing the failure and adjusting.
So what happens when the human element is introduced? Like when a driver ignores an automated detour and causes a crash that blocks everything?
The AI runs the simulation with variables specifically designed to mimic human irrationality. It subjects the digital infrastructure to infinite stress tests to find the singular path of maximum resilience.
It's planning around our stupidity.
Essentially, yes. It modifies the road layouts, the power distribution grids, and the foundational supports over and over until it arrives at a design that naturally absorbs that human chaos without triggering that cascading failure we talked about.
So it's actively designing physical environments that are immune to our mistakes.
It ensures that when the robots finally show up to the dirt to do the physical building we discussed in the first part of this deep dive, they are executing a literally mathematically perfected plan.
Man, that is so... The blueprint isn't just a drawing. It is a battle-tested digital reality that has survived millions of virtual disasters before a single physical dollar is spent.
That's exactly what it is.
That is just incredible. And, that leads us logically to the ultimate question for you, the listener. We've explored the real-time nervous system of the robots on the site. We've explored the massive generative AI simulations that stress test whole cities.
The whole ecosystem.
Right. But what is the tangible payoff of this massive technological shift? Why rewrite the entire history of human construction?
Well, our source material distills the outcomes down to three primary tangible benefits, and those are speed, cost efficiency, and reduced human risk.
So what does this all mean? Let's bring this right down to the ground. If you are a real estate developer or a city planner or even just a taxpayer, those first two benefits, speed and cost efficiency, those are pretty standard tech industry promises, right?
Right. Everyone promises faster and cheaper.
Exactly. You run a simulation, you don't make mistakes in the real world, so you build faster and cheaper. Measure 1,000,000 times in the cloud, cut once in the real world.
And those two, the speed and cost efficiency, those are direct products of the simulation phase we just discussed. You aren't wasting materials tearing down physical mistakes.
But I want to spend some real time digging into that third pillar, reduced human risk. Because we always hear about AI saving money and time.
Yeah.
But is the reduction of human risk actually the most profound change here?
I believe so, yes.
Because saving money, that's a spreadsheet benefit. But we are taking humans out of the line of fire in one of the world's most historically dangerous professions. That feels profoundly different. That isn't just a software upgrade. That's a fundamental rewriting of how civilization expands.
This raises an important question, really, about how society will ultimately redefine the concept of physical labor entirely. And you are entirely correct to anchor on this. The reduction of human risk is the most transformative element buried in this source material.
It's the silent revolution underneath all the tech jargon.
Exactly. Because for the entirety of human history, the act of building grand structures has required an explicit toll in human health, safety, and life.
Think about the history of architecture. Every great wonder of the world, every massive bridge, every towering skyscraper in your city is, on some level, a monument to broken human bodies.
It's a dark reality of progress.
It is. People fell, people were crushed, people breathed in toxic dust for decades just to put those steel beams in the sky. Progress has always demanded a blood sacrifice.
And what this AI integration does by utilizing the physical robotics on the ground directed by the cognitive digital brain we started with is finally decouple human physical sacrifice from societal expansion.
Decoupling human physical sacrifice from societal expansion. That right there, that is the massive aha moment of this entire deep dive for me.
It changes the entire moral calculus of building a city.
If the AI is testing the building in the cloud and the robotic drones are carrying the steel on the ground, the human being is no longer the raw, expendable muscle of the project.
Right. The human transitions entirely out of the physical danger zone. They become overseers, creative directors, and systems managers.
They're sitting at a desk.
Yeah, they monitor the data streams from air-conditioned control rooms safely away from the suspended loads and the heavy machinery. The human is no longer holding the hammer. The human is observing the digital nervous system that commands the hammer.
But what happens to the culture of construction? I mean, there is a massive global workforce built entirely around physical labor. If we remove the physical toll of progress, how does society manage that transition?
It requires a massive psychological and economic shift. The very nature of a hard day's work is redefined. But purely from a safety perspective, it is a monumental leap forward. Consider the economics of an accident.
Okay.
In the traditional model, when a human being makes a critical physical error due to fatigue or suffers a mechanical failure 50 stories in the air, it is a devastating human tragedy. Families are ruined.
And the work stops. Investigations happen. The emotional toll on the crew is massive.
Absolutely. But in the automated model, when a lifting drone makes an error or a robotic arm suffers a mechanical failure, no one goes to the hospital.
All right, it's just broken hardware.
It is just a line item on a budget. It is a repair cost. AI is moving city building from a dangerous physical necessity with a high mortality rate to a safe, purely logistical exercise.
It really reframes how you look at the world around you. You go from a reality where building a massive suspension bridge is this daring, dangerous, and often tragic physical feat, to a world where it's a matter of hitting execute on a perfectly simulated digital model and watching a synchronized robotic workforce just pull it out of the ground safely.
And that is the true underlying promise of the automated city outlined in our source. The flashing lights and the robotic arms, they look very futuristic and cool, but the core achievement is fundamentally upgrading the basic safety of human progress. We are engineering environments that are not just mathematically efficient, but entirely divorced from human physical peril.
Which brings us full circle to the end of our journey today. Let's quickly recap what we've unpacked for you. Artificial intelligence is no longer safely contained behind the glass of your phone. It is actively becoming the central nervous system of our future physical reality.
It's building the world around us.
Exactly. It begins in the cloud, running millions of generative simulations to perfect the infrastructure of an entire city, eliminating those cascading failures and guaranteeing speed and cost efficiency. Then, it translates that battle-tested digital blueprint into the physical world, acting as the real-time cognitive conductor for a robotic workforce.
The physical execution layer.
Right.
Yeah.
And the ultimate payoff isn't just saving money, it is decoupling human physical sacrifice from the expansion of our cities. It's a total transformation from the digital simulation down to the robotic execution on the dirt.
It is the complete closed-loop life cycle of the new automated city.
Now, before we let you go, I want to give you a quick teaser. Today, we focused heavily on how these automated hyper-intelligent systems are physically building our infrastructure. But in our next deep dive, we're going to pivot entirely.
It's going to be a very different conversation.
Very different. We're going to explore how these exact same advanced simulation technologies and autonomous robotic systems intersect with national security. You definitely won't want to miss that one. But to leave you with something to chew on regarding today's exploration.
Yes, I will leave you with this final lingering thought to consider as you go about your day. We've established that artificial intelligence is perfectly optimizing our future cities for speed, cost, and maximum physical resilience. It is mathematically eliminating bottlenecks and friction.
Right, the perfect city.
But friction is often where culture lives. How will an AI account for the inefficient, messy, organic human elements that actually make a city feel like a vibrant home? In its ruthless quest for perfect infrastructure and mathematically flawless traffic flow, can an AI truly simulate the soul of a city?
Wow, that is a brilliant and honestly a slightly unsettling question to end on. Because a perfectly efficient, frictionless city with no soul isn't much of a city at all. It's just a motherboard we happen to live inside. Think about that the next time you walk through a chaotic, messy, wonderfully inefficient neighborhood. Thanks for joining us for another episode of AI 10X, brought to you by 10 Leaves.